This is the solution video for section 8.4, problem number 5. All right, so it says the ends of an 8-foot long water trough are equilateral triangles having sides of length 2. If the trough is full of water, find the work required to pump all of it over the top. All right, so first of all, you have to understand what we're actually looking at. All right, so we have this water trough that has triangular sides. All right, so my best attempt to draw this. All right, so we have this trough, kind of looks like this. Right now, it's full of water. All right, now you're going to put a tube in here once again, and you're going to pump the water over the top. All right, so what we need to do is, first of all, we need to think about the slab of water. So remember, if we take a horizontal cut of this trough, what do we get? Well, we actually get a rectangle, right? Now, it's easy enough. You're told that it's an 8-foot long water trough, and the triangles on the ends have 2-foot sides. And so the common thought is that the rectangle of water here is an 8x2 rectangle. It is not an 8x2 rectangle. It is 8 feet long, right? Every bit of the trough is 8 feet long. But remember, let's say that I take the triangle and I just put it flat here, okay? The top of this is 2 feet, right? So that means the slab at the very top of the tank, yes, is 8 feet by 2 feet. But think about the slab that's somewhere in the middle. How wide is it? Well, it's not 2 feet wide. It's actually some variable amount. So let's call it W. So every slab is 8 by W in area, which means the volume of every slab is 8 by W by, now here, it is not dW, it's dy. Remember, it is dependent upon how far this slab is from the bottom of the tank, right? So you have to deal with this. How are W and Y related? All right, so what you want to do is you want to remember, if I were to draw in the altitude here, right, we actually get a 30, 60, 90 right triangle, right? So this is 90, obviously 60, 30. So if this is 1, right, half of the top, this is 2, that means this third side is root 3, right? And so that means that if I want to figure out how W is related to Y, I can use a similar triangle. So I can say W is to Y as 2, this whole distance here, is related to the height here, which is root 3. So this is what we would say. W is to Y as 2 is to root 3. So W is 2 root 3 over 3 times Y. And so that means that the volume is actually 8 times 2 root 3 over 3 times Y times dy, right? So that's the volume, right? And then, of course, to get the weight, you're going to multiply by that by 62.5. So I have 16 root 3 over 3, and then times 62.5 pounds per cubic foot, and then I have the y dy. All right, so all of that is the weight. Now, the distance, how far does each individual slab have to travel? Well, the total height is root 3. So root 3 minus the height y that it is off the bottom of the trough. All right, and so what are we going to do? We are going to integrate this weight times distance. So 16 root 3 over 3 times 62.5 times the root 3 minus y times the y dy. I always put the dy at the end. All right, now you're going to integrate that from the lowest slab of water, which is 0, to the highest slab of water, which is root 3. Okay, now, of course, this one would be very difficult to calculate without a calculator. All right, so you want to calculate this. Now, the easiest way to do it is to move all of these constants out to the front. 16 times root 3 over 3 times 62.5. Then integrate 0 to root 3 of, well, you could distribute that, and it would be root 3 times y minus y squared, and then with respect to y. Okay, so now make sure that you can calculate this. I believe the result should be 500 foot-pounds.